So a lot of times I'm asked, what does the Savvy Inspector actually do? How are you measuring the scratches? And that's always a loaded question. There's a lot of misconceptions in the industry that the scratch number is somehow related to the size of the scratch. And if you know me and you've seen any of my papers, you know that the scratch number is not related in any way to the width, depth, or any other physical dimension of the scratch. The scratch number is simply a measure of the brightness of the scratch, and it references it back to the limit masters at Picatinny Arsenal. Right? So MIL-PERF 13830, which is the de facto standard for scratch and dig in the world, is a specification of the visual appearance of imperfections on optical parts. It uses two numbers. The numbers are arbitrary and don't reference to any particular dimension, but reference the brightness of a scratch or the apparent size of the dig. Okay? So that's the standard that we use. That's the way the scratch and dig system works in the United States and really throughout the world. That's what we mean when we say 60/40. Now, our system actually isn't a person looking at a part, and that's the only difference between the way the Savvy Inspector works and the way you do a visual inspection. When you're doing a visual inspection, you take your comparison standard and the part you're trying to measure and you look at them together. And you compare how bright the imperfection is that you're looking at with how bright the comparison standard is. And the comparison standard is traceable back to the Army. It's a visual brightness comparison. So that measurement is really just a scatterometry measurement with the human observer acting as the eyeball, right? So your eye has a limited aperture and it can only detect scattered light coming from particular angles. And the light source is specified very carefully in the MIL standard. It has to be a very specific size and a very specific position. And you have to hold the parts in the right place, and you've got to illuminate them correctly. And that's how you make your measurement, right? That's the way the MIL standard is supposed to work. Well, all we've done with the Savvy Inspector is we've replaced the human eye with a camera. And the camera has a fixed aperture. And that camera is looking down through a dome. This is just a barium sulfide dome with some LEDs pointing up at it. And the angle of the dome is set to exactly match that of that visual reflection inspection. So that's how the Savvy Inspector works, is it's doing a reflection scatterometry measurement that exactly mimics that visibility inspection that your inspectors are doing on the floor. And the only real difference is this system doesn't get tired, this system doesn't have bad days, and the system always gives exactly the same answer no matter who's loading the parts and who's trying to measure them. That's the big difference. So you get this objective measurement of surface imperfections rather than the subjective measurement that's required by the MIL standard. So you load the part and you actually look at what the scratch brightness value is by comparing it to a calibration file. These calibration files are effectively the same thing as the comparison standard that you would use in a visual inspection. Each one represents a different physical artifact standard that you might want to use for your visual inspection. Now, in most of my videos, I'm always showing ANSI Army as the standard calibration file, and that's because that ANSI Army file is actually a calibration file based on the actual limit masters at the Picatinny Arsenal. So it's as close as we can get to a MIL traceable inspection. You load the part that you're interested in evaluating, you put the imperfection into the green square. Anything in that 1 millimeter green square is going to be reported in terms of scratch and dig value in the upper left side. So in this particular case, this scratch is a number 80. And you can also see that in the color bars. The number 80 specification line is this red line here. And the scratch is currently running somewhere between the 60 and the 80 mark. Anything that's higher than a 60 but less than an 80 is called an 80 according to the ANSI rules. Now, we can actually change one thing that we can do with the software that you can't do with your eyeball is we can actually dial in exactly what the specification is and then get an immediate go, no, go response as to whether the part passes or fails. In this case, I've selected the number 60 as the go, no, go limit, and you can see that now the bar turns red because the scratch is larger than a 60. So what you're really doing is you're doing a visibility inspection with the Savvy Inspector. You're not doing a measurement. So when people ask me, are you measuring the scratch? The answer is not really. I'm actually measuring the brightness of the scratch, and then I'm documenting that. And of course the software has all the features that allow you to document the image that you're getting, and to actually accumulate all the information you need to know about the imperfections on a part in order to decide whether it passes or fails.